fortune is what happens when opportunity meets with planning. New knowledge is the most valuable commodity on earth. The more truth we have to work with, the richer we become. A very good morning to all. I feel privileged to extend my warm welcome to one and all for the day 6 of International Online Faculty Development Program on Perspectives of Artificial Intelligence Applications on behalf of the Department of Electronics and Communication Engineering, St. Joseph's Institute of Technology. I am Subhashri from the Department of Electronics and Communication Engineering, here to host today's session. On this pleasant morning, we would like to cordially welcome our guest, Dr. Suresh V Rajappa, Senior IT Management Consulting Professional, as our honorable speaker. We would like to welcome you, sir. Thank you for accepting our invitation and joining us to share your knowledge. Welcome, sir. Our respect and gratitude to our management, who have always been a great source of inspiration for us. It's a pleasure to welcome the heads and all our ACE staff members. Last but not the least, I welcome all the participants. Welcome you all. Here are a few words about our speaker. Dr. Suresh V Rajappa, PhD, PMP, MBA, Director Enterprise Systems, KPMG LLP, USA, is seasoned senior IT management consulting professional with 24 years experience leading large global IT programs and projects in IT strategy, finance transformation strategy, BI, and data warehousing or data management for clients across diverse industries, generating millions of dollars to top and bottom lines. Successful recruiting and leading onshore or offshore cross-culture teams to deliver complex enterprise-wide solutions within tight deadlines and budgets. Highly effective at breaking down strategic program or project initiative into tactical plans and process to achieve aggressive customer goals. Inspirational, solution-focused leader with exceptional ability managing multi-million dollar P and LS budgets and change management initiatives. Before getting into the session, I have few instructions to the participants. Participants, kindly mute your mic and video. Kindly post your queries in the chat box, which would be answered at the end of this session. The feedback link will also be provided at the end of this session. Machine learning is the last invention that humanity will ever need to make. I consider it a great honor to have Dr. Suresh Rajappa sir with us today. We are eagerly waiting to get enlightened with your knowledge, sir. I request you to start the session, sir.
Thank you, Subhashri. Let's start the session. Let's start the session. So that today's topic is machine learning in bioinformatics and how we can implement machine learning in bioinformatics, and what are all the practical challenges we'll be facing when implementing those machine learning algorithms. So the agenda is basically what is bioinformatics and what is how the machine learning can be implemented in bioinformatics domains, and what is machine learning algorithms in bioinformatics, and what are the applicative areas for machine learning in bioinformatics, and the practical challenges in implementing it, and then final remarks and references and further reads. And obviously, there will be a question and answer session at the end of the presentation. So that being said, let's jump into what is bioinformatics. Bioinformatics is a computational and mathematical field and which implements the approaches of computer science, mathematics, statistical, and biology to understand and process the biological data. We just focus on the biological data. This study of the data, biological data, have been in various applications. The various applications in the bioinformatics, from sustainability of biological processes to the life on our planet. Okay, so bioinformatics is an emerging interdisciplinary, as I said, science of interpreting the biological data using such adaptive computational procedures. And last 5-6 years, bioinformatics has been more popular popular across the world because of the computational power what the computers have, and the storage capacities what current computers have, and the processing capacities what computers currently have. Okay, that being said, so there are multiple areas. Areas of bioinformatics we can talk about. So the evaluation sciences and the text mining, or proteomics, where study of proteins, etc. Genomics, where study of genes, gene sequencings, and other things. In the proteomics, we can talk about the function prediction. So each protein has different functions and how to predict that, and the structure of the protein, um, and how to predict that, and the systems biology, and also the other applications we can talk about it. So these are all the different aspects of bioinformatics. That being said, they can be grouped into 4 different categories or 4 different groups. Omics sciences. So don't get carried away with omics sciences. It's nothing but genomics, proteomics, and metabolomics. So whichever ends with OMIC, right? So they are grouped into omics sciences. And the system biology, like a molecular analysis, functional meta-analysis, clinical data, modeling of biological networks, etc. Right? So those are the 2 major applications of bioinformatics. And the computations comes into 2 parts, where the algorithms are for the analysis, algorithm development and training, and and testing of the algorithms, and storages. These storages, the databases. Currently we get the structured, semi-structured, and unstructured data for the bioinformatics area. So just the relational databases will not be suffice. So if we talk about the storage of the databases, we can go deeper into the big data and how to store, how to disseminate, and all those things we can talk about it. But that is not the focus of today's session, right? The today's session is basically the algorithm development and analysis, and how each of the other 3 parts of a triangle touches it. Okay. So that being said, before jumping into the deep into the bioinformatics, right? I want to just define the AI, machine learning, and deep learning, right? In a nutshell. So what is AI? AI is nothing but it's the broader concept of machines capable of performing the human tasks, right? Or if consider as the smart tasks, thinking and reacting, not acting, reacting to the reacting to the questions and the intelligent behavior, etc. So AI is the overall umbrella, and machine learning is a subset of that. Basically, it uses the algorithms, and it uses the statistics and algorithms, right, capable of learning from the data rather than being explicitly programmed. See, in the real world, what we do, or in the regular olden days, what we do, we write a program, right? We pass the variables. We define the variables. We pass the values to the variables, and we get the output of the data. So the program is stable, and we change the multiple variables and multiple inputs to get the different data, different set of results. The results will be always similar results, right? Whether if you want to, for example, right, C equal to A plus B is a program we can return, right? We can change the values for A and B, but always we'll return the values as C. So the program will return always the value of C. The value of C might be different, but it returns the C. right? So let's talk about, I mean, in next few slides, we'll talk about what are the difference between the machine learning and the regular programming, etc. Um, the next topic or subtopic is deep learning. Deep learning is basically the subset of machine learning, which uses the mixes of guided and unguided, which is supervised and unsupervised algorithms, along with the neural networks, right? And thus reduces or he removes the need for human interventions, right? And let me explain how neural networks or the deep learning can be useful in in the bioinformatics area in the later slides. Okay, so if you want to define it, right? So machine learning is one of the subset or very small subset of AI. The robotics is one of them. NLP, natural language processing, is one, and expert systems, right? Machine translation and text to speech, speech to text, all those things are part of the AI. Visions, computer visions, right? And planning and scheduling of these systems, right? Search optimization, right? So the search engines and other things uses this kind of search and optimization area of it actually. So to define that, so we are talking about the machine learning, and under that we have deep learning, predictive learning, anomaly detection, and trend forecasting. Okay, so these are the subtopics, just to give a overview of what is machine learning, and then we can talk about any of the adaptive areas, like whether it is biology or any other area, what we can think of, right? How we can implement it. So today session we are talking. I'm taking the use cases of biology or bioinformatics and how the machine learning can be implemented. Okay, and talk about the machine learning as a traditional programming paradigm, right? So traditional programming, what we do is we write a program, we feed into the computer, and we feed the data, that's the variables, and we always get an output, right? The output will not change, as I said. So the program will be C equal to A plus B. Always the output will be written as C. Okay, but in the machine learning, right? So what we do is we have the data, which is the test data and also the train data, right? And we have outputs optional, right? So if we know what we are trying to achieve, outputs, right? The achieve, or what we trying to predict or analyze, right? Which is my supervised learning, right? I'm training the model or giving the input to the model, saying that look for this pattern or this values, etc. Right? That is my supervised learning. And sometimes unsupervised learning, right? We don't know anything about the data, right? We need to understand and learn about the data, right? That is that time we will not give any outputs as such, right? So what we do is we know the data, which is my trained data, and what will be my output or what will be predicted values should be, right? And we create a model, right? We create a statistical model, right? Where we implement, we implement the algorithms for machine learning or deep learning for that matter also, right? So for example, right, it's a ground truth. We know exactly what data we have. That means that we have a test data set, right? And this is the answer key. What we are trying to predict the values from the ground truth, right? And the ability to learn without being explicitly programmed. For example, right? So if you are clustering, clustering is one of the tools or one of the algorithms we are using it, right? So we don't know anything about the data, right? So how we are going to group the data, right? Basically, we create a model and we group the data into multiple groups, subgroups, so that we can understand a lot of things about the data, and then we can process the data much better, right? And so that is what we talk about the machine learning paradigm, and we are not defining the output, right? Output can be anything. A lot of times we get surprising output, surprising trends, etc. So I've been talking about machine learning. Machine learning is generally categorized into three different categories, right? Supervised, unsupervised, and reinforcement learning. And people call it as, semi-supervised learning, which is in between supervised learning and unsupervised learning. So the difference between the supervised learning and unsupervised learning is the data is labeled, or we know a lot of things about data, right? And we predict the outcome or the future of the output. But in the unsupervised data, we have no labels, or we don't know much about the data, right? We are trying to understand the logic behind the data, right? Reinforcement learning basically it is giving the feedback loop, right? Basically an action can be done, taken, and for that there is a reaction, and if the action is positive, then we'll reward it, right? So in the supervised learning, we talk about something, looking for something specific information. And unsupervised learning, we understand the data. That means that, here I will give that output. From the previous slide, I can talk about. So I give the output, right? I define the output, what I'm going to predict it. Here, unsupervised learning, I don't know. So I get to understand about the data, right? Reinforcement learning is basically the reward based on the random actions. For example, right, if you're playing a chess, right, there are multiple moves, and each time we'll have a different move, right? So that is called reinforcement learning. Based on the move for the opponent, or this, the next move is planned. If you think of that, okay. And I think, yeah, I gave it 5 minutes overview of machine learning algorithms, and the groups in the machine learning, etc. Now let us jump into some of the concepts, or some of the models what we can create, or algorithms what we create, and the applicative areas for the bioinformatics. So what is the main purpose of using machine learning, right? It's the machine learning model. The main objective is to attain the good generalization performance, maximizing the prediction accuracy, right? It's basically to give more accurate values or results, because we are dealing with human data, or human we are talking the human lives directly, right? So the accuracy is more important than any other industry. For example, if you take a finance industry, or a creative industry, or any other industry, automotive industry, or any industry, accuracy can be little less compared to the bioinformatics area, thus minimizing the probability of making the wrong biological prediction, right? This is when I cannot stress more on on this last point, minimizing the probability of making the wrong biological decision or biological prediction, because always we are dealing with human lives in this one. Okay, so there are multiple algorithms we can use it. So one of the algorithms most famously used is decision trees. Decision tree is nothing but it's like a tree-like structure, right? It's a hierarchical representation of the relationship between various features of the biological data. For example, take smoker, right? We split into two major questions. What is your age, and what is your diet preferences, right? And so based on that, right, the path of the tree is split into and it goes with different path actually. Okay, so for example, right, if the smoker, this is called, the top node is called a root node, and the intermediate nodes, basically the intermediate questions, and then the last or bottommost nodes called the leaf nodes, right? So basically there are other concepts we can talk about. There are certain aspects and the weightages and other things we talk about, but because of time constraints, I'm going to talk very high level here, right? So this is a method depends on classifying a set of features through a series of questions asked. So for example, right, are you a smoker? Yes or no, right? And then, I mean, we'll ask, what is the age, right? Greater than 40, less than 40, right? What is your diet, right? So, high fat diet or low fat diet, right? So that way we categorize and group it actually. So this is the most famously used algorithms. So the leaf nodes represent the samples classified into categories. So whether it's a low risk category or a high risk category, right? By keep on asking, we can find what patient is the low risk category or high risk category, right? Currently, how in the COVID-19 or a corona predictions, right? So how they categorize the low risk patients or medium risk patients or high risk patients using decision tree algorithms, right? So decision tree is a common algorithm which can be used in any industries, etc. And in the bioinformatics area or biology area, there are specific algorithms, which are, based on the tree, decision tree based algorithms. They are ID3, C4.5 algorithm, CART, or CHAD or Quest algorithms. So if there are they use regression and the tree and all those things, right? So there are a lot of documentation and informations available in all those algorithms actually. So decision tree, as I said, it's a basic of all the algorithms, right? Which we use it for classifying it. To advance it, the next type of algorithm is called random forest, right? Think of that, right? So tree to the forest. If you, for the layman, if you think of tree to forest, right? Tree is single tree, right? Forest consists of multiple trees, right? So that is the structure. If you think of that, random forest is basically the forest structure of randomized construction of several decision trees to classify the item sets. So each feature will have a different tree structure, and each tree will have its own its own result set, and big majority voting will be the final class. We call it as a final class. So this is repeated multiple times, right? The prediction is simply be the mean of each prediction. So every time we do it multiple times, or we do this a random forest classifier multiple times or run it multiple times, right? Since it captures the variance of different trees, right? It supports good predictive model, right? We are taking multiple features and building a tree and combining it to that. That being said, right? So random forest usually takes longer time because it's not one tree, right? It takes multiple trees. So to make it faster, XGBoost is proposed, right? XGBoost is a idea or the or the algorithm, right, where we can which exploits out of code computation, or the it's more than algorithm, we can say architecture is the XGBoost architecture, right, which exploits the out of code computation and scales to the larger data, right? So we talk about the decision tree and the random forest, right? Next will be simple vector machines or SVM. This is the most popular nowadays, right? So it's basically the algorithm starts with plotting each data or a feature into the n-dimensional space. that has nth feature basically to coordinate the geometric plane. For example, if we take two sample features, right, like what we talked about, age and the smoking status with respect to an individual. So we are defining two classes, class 1 and class 2, right? It's two-dimensional space where each point has two coordinates, or which are known as support vectors. This was proposed initially from Drucker et al. At 1997. This concept was proposed for bioinformatics. The aim of this model is to find this line that splits the classes, the class 1 and class 2, right? That splits the this line, the center line, not the dotted line, the solid line, right? That maximizes the distance gap between each point of the two groups. For example, right, what is the distance between these 2 points, right? For this point, right, each point from the vector line. So it classifies this into two classes, class 1 and class 2 as such, right? Whether it's in these simple terms we talk about it, class 1 can be high risk, class 2 can be low risk patients. The idea is same, but we are using different models and the implementation architecture, how we are going to implement it. Okay, so the clustering, right? So we talked about the decision trees, random forest, and SVM, simple vector machines, etc. Right? So if we don't know much about the data, right? We don't know much about the data, right? The data comes like this on your left-hand side, right? In raw log data, log messages, it comes, right? So we use the classifying algorithm or clustering system to group it into multiple groups, right? It's a technique which arranges the biological data into groups. Groups are most common features of each group is contained. That's called clusters. So instead of this, we grouped into 3 clusters here. So the groups are known as clusters, right? Clustering methods can be classified into like following main categories, right? So there are multiple methods you can use to do the partitioning or the grouping. So there are 2 main methods. Main methods we can talk about it. So partitioning method and hierarchical method. So in the partitioning method, we talk about, right? So we do the partitions, the number of partitions, right, which are less than your number of data elements. We call it as partitions as k as partitions, and which are less than number of elements, which less than or equal to number of elements, which is categorized as n, number of elements. So there are 2 popular algorithms or heuristic methods. You can say k-means algorithms, k-medidoids. So means and medians, if you think of that. Okay, so the second type of method is called hierarchical method. It's basically it's based on the hierarchical decomposition of the given set of items, right? So we can do it bottom up or top down based on the directions of the decomposition. Decomposition is nothing but splitting the values into small groups actually, right? So each step, when we split into details, each step we'll do the hierarchical method and look at the values, and then we do the decompose next level, and we group these similar groups into categories. Categories are clusters, right? So there are multiple methods we can do it. So the density-based methods, where where it focuses on the density, which is number of items in a cluster, right, which exceeds the given threshold. Grid-based, the quantity, grid-based is the second one, and it's basically based on the quantizing or clustering the items into a finite number of cells. It's basically put as a grid, and then take it. For example, if you from this box, if you do the multiple grids, right, and then define the grid into multiple clusters. The more common is model-based methods. This is mostly used actually. So it's mostly used to hypothesize clustering of constructing of the model for each clusters and finding the best fit of the data, right, to the given model. So this is the model-based methods, or the most commonly used clustering algorithms, clustering method in the hierarchical sub method to do the clustering. So if you take Python or any other language, right, Perl or R, etc., right, the clustering logic will have this, this parameters. You can define it to get it. This is much simpler to do that in the language, but understanding why we need to use it, how we need to use it is the key, right? Applications and which method we need to use it for the applications, right? So the clustering example can be, right? So in the real world, how we are currently doing it, right? So the question to you, or question to the government is, right, who to be tested for COVID-19 positive or COVID-19, right? So we use this kind of clustering methods, or called pooling of the data, right, and categorize as the low risk, medium risk, and high risk clusters, so that we can focus on high risk clusters and reduce the impact of coronavirus to the whole population. Okay, so we talked about reinforcement, reinforcement, right? What is reinforcement learning? It's a systematic approach of behaviorism in psychology, right? So this is basically used, used in the psychological studies, etc. Right? How human behaves in a particular study, right? Kind of implementations, right? So there are certain agent, certain things we need to understand, right? It's a set of environments or agents, right? And then set of actions that need to take, right, on the agent, and then what state, right? What is the state? Set of actions, and what is the state, right? Whether it is whether it's the positive state or negative state, right? And then reward. Reward is basically giving, giving feedback to the agent and to the, to the actions, right? For the predicting of the correct results, right? If it is, if it is predicting wrong, so we'll fine tune it and then we reinforce it, right? So we teach the system to learn. So we reinforce it constantly. We we follow this, follow this process. So this is implemented, majorly implemented as a Markov decision process, which relies on learning agents taking actions for a given environment, right? So basically there are agent, environment is the, environment is the area by which the action is taken by an agent, and which produces a state, yes, and it can be rewarded or, right? The probability of transition from one state to another, which belongs to the state yes, under the action A. Okay. The reward is the reward while transition. A transitioning rule describes the agent's observation, whether it can be positive or it can be negative reward. Okay, so this is another basic thing. Um, another basic or mostly used algorithm is called associated rule mining. In the real world or in the COVID-19 world, we talk about. They come up with multiple apps like ROK Setu and other things, right? And they use associated rule mining algorithms to trace the contact. To do the contact tracing, right? So we get multiple transactions, right? And we associate the transactions into multiple groups, right? So it's association of linked analysis, alternatively known as the affinity analysis, right? In the real world, the COVID-19 cases, we call it as contact tracing, right? Basically, it's the for example, right? I have multiple values, so I can group it into multiple frequent items, right? Whether this patient is done A, B, C items. If that is the case, okay, trace back to the next level, next level, right? The association rule mining or associated rule mining, in the short form we call it as ARM, right? ARM, which is used in the current situation as COVID-19 cases, right? It is first for the biological studies. It is first proposed by Karthikeyan and Ravi Kumar in their 2014 research. The implication expression of the association rules of the form X to Y, where X and Y are the feature item sets. X belongs to Y, or X relates to Y, if you think of that. Useful in bioinformatics, it's find the co-expressed genes and with their functions, right? How the gene behaves, and and other things we can do it. But to give an example, in the real world, what we are currently seeing in the contact tracing is the frequent utilization of this algorithm. Okay, extreme machine learning is the next algorithm, right? Which uses a single layer, a hidden layer of the neural networks. Don't get carried away. I may carried away with that. What is neural networks and see what is single hidden layer, etc. I'm going to talk about that in future slides. Where we use the output weights that are calculated by least square method, which makes this neural network is much faster, right? It's very high performance because of the volume of data, right? Volume of data, we need fast results and quick results, right? This extreme machine learning or EML is basically is more useful process for us. Okay, so how we can use the neural networks, right? Input layer on output layer, and in between it's called hidden layers. Okay, so what is it? ANN or artificial neural networks. It's basically mathematically modeling the human brain, how human brain thinks, like neurons, right? That's what it's called, neural networks, right? There have been a lot of neurons in your brain which links from one set to another, right? And there are intermediate processing called hidden layers, and and they are called they're called nodes. Actually, neurons are nothing but your nodes, right? So input biological features, right? And they are sequenced layers. They are sequence layers, right? I'm showing one layer, but in the real world, I have seen 17, 15, 16, 17 layers actually of neurons. So each layer, when we do the processing, it takes a lot of time. right? So basically, it's the sum of, right, WIXI. What does that mean? Weight and the number of inputs, right? So here in this case, I have two inputs, right? And I given weights to different, different inputs, and it's a summation of it actually, where I is the 1 to, like 0 to number of inputs. It changes, which varies actually. So the processing unit are organized into layers or multi-layered perception. The values are the parameters, basically nothing but your weights, right? And we can talk about the ensemble learning and other things, but for the time constraint, I'm going to limit my conversations, conversation to just to introduction of the introduction to different algorithms. Um, another advanced level of artificial neural networks is called, right, deep convolutional neural networks, deep networks, or connects, right? It's three-dimensional, right? From the single two-dimensional, we are using three-dimensional, nothing but your depth, width, and height, W, H, and D. We use it, unlike the 2D neural networks in the previous cases. This these neural networks are successfully being used in the drug discovery processes. The potential treatments that could be derived from predicting the interaction between the molecules and the biological proteins. Right, one of the implementations, what it's called AutomNet, which is introduced in 2015. In one of the relational drug design, drug design research paper. Right, so CNN or convolutional neural networks or deep neural networks is the one of the concepts. It's popularized in the areas where there are lot of data is available. One, and second is the accuracy is more more important than just predicting it. It's 99.5% accuracy than the 95% accuracy or 90% accuracy in the regression models and decision tree models, etc. Okay, so I touched in the like multiple algorithms, whether it's a machine learning algorithms or deep learning algorithms, which are used in the bioinformatics world. If you think of that, right, nowadays we get large volume of data, multiple sources of data, right? Multiple sources of data, right? So we get lot of data which are redundant or irrelevant for our for the analysis purposes. So we need to understand which feature is useful for my analysis, or which dimension is useful for my analysis or significant for my model, and other dimensions or other features we can eliminate it, so that we can reduce the size of the of the sample or biological sample space, so that we can attain the relevant biological features, so that we can improve the quality of the results, right? So there are multiple ways to do it, right? To do the feature feature selections: filter based, wrapper based, and embedded approaches. The most popular is embedded approaches, right? So what is filter method? Basically, they extract the features based on the general data properties, so that we can rank the the features, right, 1 to 10 or 1 to 100, right? And then take the top 50 features, so that we can reduce the size or the dimensions of the model. That's called filter methods. The wrapper methods is basically estimating their accuracy using a machine learning schema itself, right? So we use the training data. I mean, so when we get the data, total sample data, we split that data into 80-20 or 60-40. Training data to my test data, right? 80-20, 75-25, or 60-40 percentage different. So we train the data, right? And then we look at the look at the result set and understand which features are useful for us, and then we eliminate some of the some of the features by by optimization feature called either forward or backward search of over the biological input data. The embedded methods is basically it's incorporate the feature selection strategy as part of the ML model. There are most famous ML feature selection model is called PCA, principal component analysis, and there are other models also available. Principal coordinate analysis, COA, linear discriminant analysis, LDA, etc. Okay, so these are the ones which we can talk about. I mean, each of the topic, for example, right, PCA is a deeper study. We can talk about then the later. I mean, if we have if we have organized for the later sessions, we can take each of the models and we can talk or we can go deeper into each of the models the models more thoroughly and get it actually. Okay, and so where this this machine learning is implemented in the different areas, right? Diagnostic or treatment of diseases, drug discovery, right? Biological and medical image processing, right? Currently the radiologist or people are looking at your x-rays or scans, etc., and predicting or looking at it and finding the diagnostics, etc., right? Those can be automated by machine learning and deep learning, so that so that the manual interventions can be reduced and the results can be much faster. In the COVID-19 cases, right? There are multiple ways multiple ways the biological testing, biological and medical images and testings can be done to improve the accuracy of the test results. And genomic composition and sequence analysis, right? Molecular modeling, right? Biodiversity is another thing, and persuasive and mobile technologies like Arogya Setu and other things what we currently are implementing, right? So they are implementing machine learning in the healthcare. Let's talk about the challenges. I think I'll talk about 5 minutes on this topic, and then open for the question and answers. I know it's I'm taking a little bit of time. Please bear with me because the topics are too wide and too deep, so I got to do it. So basically, according to the research done by various universities in the bioinformatics, there are 4 major challenges, right? Data deluge issues. As I talked about it, there are vast amount of data is coming into picture, coming into the stream and pictures. So how we can reduce? How we can impact the data deluge issue? Knowledge management. Basically, how to predict and deliver the personalized medicine. The personalized medicine concept is most famous. Most famous, and it's picking up more and more nowadays. Instead of prescribing a procedure or process or a treatment plan for a patient, generic prescription or generic treatment plan. So they want to, based on multiple symptoms and multiple coordinates of the data, right? Currently they are doing a personalized a treatment plan, so that the success rate of the of the patient getting cured is much better. So let's talk about a few seconds on this one, right? So as we talked about it, we get a data. We get a lot of data. We get a lot of data currently. Right? So the storing the data, right? Storing the data and disseminating the data and retrieving the information out of the data is key, right? So what we do is we can implement a distributed architecture as shown here for the machine learning algorithms, instead of putting it putting it in one boxes, etc. And the basically, right, so the distributed the machine learning algorithms can accommodate the distributed architecture and work well with it, right? That is one key aspects of reducing the impact to that, so that this distributed architecture, right, can retrieve the information and process the information much faster in the in the parallel way, not the sequential way, right? Another way is doing right is when calculating the value for the documents, right? So we basically understand and analyze, right, and put a value to the document. The value that the document is what is the value to my model, or how relevant my model is, right? Or how useful this document or this information is to my model is called it's called the value, predicting the value or calculating the value, right? And basically what we can do is, right, we can do the vectorization, right? So we can do the king to the queen, right? We can associate it, and like men to women, right? Like a tense, right? Present, like continuous tense, like walking, past tense is walked, so we can link it, right? And the country to the capitals, the country to the languages, right? We can do we can do the vectorization process that can reduce the impact and improve the performance of the of the values actually. Okay, and basically, right, manage the knowledge base is like another thing is managing the knowledge base is the key, right? So there are a lot of documents coming in, and we need to make sure that which documents are useful for us, right? So one of the one of the results, or improving one of the ways to improve the machine learning predictions is basically digitization of the handwritten documents. In the medical world, they call it as EHR and PHR, electronic health records and personal health records, right? Now, now everything is going to be digitized across the most of the world, especially in India. There are a lot of a lot of initiatives our government is taking to digitize the handwritten prescriptions and all those things, so that the accuracy of predicting the predicting the results or outcome is much more sophisticated, right? There are multiple stages of knowledge management, right? Text and data mining. So I'm not going to go deeper into it. Basically, the linguistic analysis, etc. Right? For the time, because of the time constraint, etc. Okay, for now. And basically, basically, they predict the scientific experiments, not explaining the results, right? So machine learning cannot formulate the hypothesis on its own, but it may simulate the experiment until it happens, right? It can simulate multiple iterations to make sure that it predicts correctly, right? So one of the challenges, challenges was, right, a scandal with this medications, right? There are a lot of they're not done. It happened in Germany, right? And they are not tested this tested when tested these medications properly, right? Or they're not they're not understood or predicted the values, or predicted the results of what are the other implications of these medications, right? So that so that when they given this medication to the pregnancy, during the pregnancy, the child, the unborn child also got affected, right? And it got abnormalities, right? They're not even tested, or the models are not the scenarios are not simulated for this scandal. And there have been a lot of issues and a lot of court cases on this. And 62, 6,000 to 12,000 kids or children got affected by this. Okay. The last challenge is personalized medicine, as I talked about it, right? Basically, understanding the medical history, genomics, right, genetics, right, and inclinations, etc., right? Understand multiple aspects of it. The 360, they call it as 360-degree view of a patient, right? And and understand, right, and give a personalized treatment plan for for this, right? And basically, this is going to be the future of pharmacology. Pharmacology is basically creating, coming up with the medications, right? And this personalized medicine comes into much more prevalent in cancer treatments or life-threatening cancer treatments, right? Excuse me. And so there are a lot of products available, available in, which are used in, used in bioinformatics area, which used for, which used in machine learning implementation for bioinformatics. So if you're interested, you can look at the Rapid Miner is one of the tool, right? BioVicar is another tool, right? So there are a lot of implementations happening, and so you can take this and process it much more sophisticated way. Instead of starting from the scratch, reinventing the wheel, you have these software tools available, and you can reinvent it for for your research projects, for your PhD thesis. If you are interested in doing a bioinformatics informatics area, you can use this kind of tools to do that. Right, MATLAB is more famous in academia, and there are a lot of proven models have been implemented in MATLAB. And another thing is called OR project, which is written in OR language, right? Bioconductor project, which started in 2006. Have more, like a more of the genomic analysis, etc. If you are interested, you can look at it. And a lot of people have, have known like Python or Perl or Ruby or etc. Right? So there are certain libraries in in Python, or or Python called BioPython, where it is suited for implementation of the Python language and machine learning, etc., right, for the bioinformatics area. Okay. And I have given some, some references and future reads for you, so that you can, you can look at it. And I have my, my email address and my phone number, which is a US-based number, right? You can contact me. Contact me for further further clarifications, questions, etc. And now I think we can open for questions.
Thank you, sir, for sharing the most informative and educative speech. Now we have few questions from our participants, sir.
Perfect.
The first question is, which algorithm can be used for bioinformatics in machine learning?
Okay. So as I talked about it, right? So there are all the algorithms what I talked about it can be used or is being used in bioinformatics.
Thank you, sir.
Right? And to explain to that, right? So in bioinformatics is a vast field. If, for example, right, if I go back to this slide, right? Excuse me, 1 second. This slide, right? So there are multiple applications you can do it, right? Machine learning can be implemented for, I mean, any and all of this, I mean, all of this and aspects and subtopics of, I mean, bioinformatics, right? But what you are looking at, I mean, the looking at is the key, or what subtopics you are looking at it. And I mean, we can talk about, I mean, we can talk about which will be most useful in certain applications. Okay. I hope I answered the question.
Yes, sir. Sir,
Okay.
and how do you optimize search engine using deep learning?
Okay. So there are, I mean, yeah. So there is a topic called, I mean, there is a topic called search engine optimization, right? That's a separate topic, and how to do the text mining and there's optimization, etc. That's a neural, I mean, that's basically based on the convolutional neural network, CN, they call it as CNN. There are a lot of materials available, and I mean, if you're interested, I mean, let me know. Please contact me. I can give some basic materials, or even research materials I can provide it to you.
Sure, sir. Definitely
Interested in doing it.
interested participants will contact you, sir. And
Sure.
what is clustering and tiling in ML?
Okay. So clustering is basically, it's basically, I mean, what is a cluster? When we talk about the English word cluster, right? It's a grouping.
Yes, sir.
Right. So I mean, so if you don't know much information about the data, right? So what we do is we group it into different groups, right? Based on the relevancy of the information. That's called clusters. Tiling is basically, right, putting it in boxes, and then, I mean, trying to fit the data within that. So we call it as a grid. I mean, remember I talked about the grid information, right? I mean, gridding, right? Grid method. So that is also, I mean, a part of the, I mean, that's also one of the applications of tiling, I mean, tile method actually. So
Yes, sir. So can you give examples for reinforcement learning in real life?
okay. So yes, I mean, forget about the bioinformatics for a second, right? Like, I mean, like Vishwanathan Anand played against the supercomputer, like called Deep Blue,
Yes, sir.
right? Deep Blue, or the chess, right? That is nothing but your I mean, reinforcement learning, because we cannot predict, right? I mean, what will be the next move or next state, right? Based on that, right, the multiple options will be open, and what are the better options to play, right? That's one of the things in the real world. Real world, they do it actually. And in US, there have been, I mean, there was a game show called Jeopardy, where where this Deep Blue computer participated as a participant, and won the prize, won the prize actually. So these are the applications actually do it. And in the bioinformatics world, reinforcement learning is basically genomics. We can think of lot of, a lot of systems biology and genomics. There are a lot of applications for reinforcement learning.
Yes, sir. Sir, and is coordinate details needed to be given as input to the SVM or only the data?
I'm not sure what they're asking. Okay, let me explain. Because the question is a little vague.
Yes.
Let me explain it, right? So the SVM, right? So we need to understand, right, what are the features first, right? And then we need to model the, we need to model the based on the dimension space. We need to do the feature. We need to flatten, or the plotting the data and the feature items in the n-dimensional model.
Okay, sir. Sir, in 3D, is it possible to use support vector machine algorithm?
Uh, I think they're asking about, 3D in the sense, deep convolutional networks. That's what I think. That's what I talked about it. And see, what we can talk about. There is a concept called ensemble learning, right? Ensemble learning is nothing but it's, putting multiple multiple what is it? Multiple algorithms together, right? To do that. SVM is can be implemented as part of the ensemble learning.
Okay, sir. Sir, what is the significance of kernel functions in support vector machine, and which kernel function do you think gives better or more accurate result?
Okay, so I don't want to get into the deeper into it. Just that's one of the larger topics we need to discuss it. Please contact me. Whoever it is, please contact me. To my email ID, sureshvg@gmail.com. I can give specific examples and how to implement that
Thank you, sir.
aspects of it. Okay.
Thank you, sir. Sir, in clustering, can grid-based method be used for numerical data, or it is only for images?
Um, I have used for, mostly for images actually, but it's not, we can use it for, use it for, what is it,
Numerical data.
numerical data also. But
Thank you.
with my examples, I have used mostly on the, the graphics or the images.
Okay, sir. So, how much percentage of error can be considered in data analysis using SVM, ANN, or decision tree?
Okay, so see, basically, right, when we train the model, right? So you will give the error, error or the acceptable percentages or success percentages or error, right? There is a concept, there is a concept called right, what is it? There is a false positive. There is a concept called false positive, false negative, right? And and other, other aspects of it actually, all they are there, right? And also, right, just because we need to get the lower the error results, we should not be looking at overfitting or underfitting the models, etc., right? There are other concepts available on that actually. Or I talked about the confusion matrix and also the overfitting and underfitting the model. So those are the concepts you can look at it, to look at the errors and how to avoid those. I can do the overfitting of the model, right, and make the error to 0, right? And when the test data comes, sorry, when the test data comes or the real data comes, it fails. There is no use in it. My model fails. So we need to make sure that we are not overfitting or underfitting, right? And those kind of concepts we need to understand. We need to discuss it or look at it for the errors actually.
Thank you, sir. So,
Sure.
why do we give different weights to same input instead of sum of weights as single weight? Shall I repeat, sir?
Yeah, please.
Why do we give different weights to same input? Like instead of sum of weights as single weight.
Okay. See, there are multiple ways to do it actually. So, see, if you, for example, right, one of the predictive algorithms, or if you want to talk about the Monte Carlo simulation, for example, right? So, individual inputs, right? Individual inputs have their own weights, right? To understand what are the importance and implications. So we can do that. Weighted average and average and weighted average rates, and also, but giving giving a individual weights, or is much better approach. That's what I feel.
Yes, sir. So, what is the accuracy of the ANN neural network in predicting the deleterious genetic variants?
Okay, So, okay, ANN's, I mean, predictive model is basically, it depends on multiple things, right? How, I mean, how big is your, how big is your train data and the test data, right? Number of features you are using it, and number of layers or a number of hidden layers you are going to use it, right? It can predict. I have seen accuracy up to 95, 94, 95% of accuracies. That being said, the more the hidden layers or the more the intermediate layers, it becomes more. It requires more processing powers, and it becomes more. Um, more. What to say,
Accurate.
a more cumbersome process. So look at some of the models like AlexNet, etc., right? AlexNet, etc., to look at, to implement implement the higher accuracy of the ANN, or convolutional neural networks.
Thank you, sir. Thank you, sir, for clearing all our doubts. And now it's time to express our gratitude. First of all, extend my most sincere thanks to the Almighty God for making today's event a resounding success. I extend a hearty thanks to Dr. Suresh Rajappa, sir, for helping us to understand about machine learning. Once again, thank you, sir. My heartfelt thanks to our management for their guidance in conducting this webinar. I also thank our heads of department and all other faculties for organizing this event successfully. Last but not the least, I thank all the active participants for your support. Thank you all.
um, before I close it, if you need this slides, right? You can, you can contact the organizers. They can provide the copy of the slides, or you can contact me for any of the questions or any of the discussions for any of the models, machine learning or deep learning models I talked about for the bioinformatics. And here is my email ID and my phone number. This is my WhatsApp number also. You can use it.
Thank you, sir. We will surely contact you, sir.
Thank you, ma'am. And thanks for all the, thanks for all the participants, and for your time.
Thank you, Dr.